For section 6.6, we are going to solve some logarithmic and exponential equations, and we're going to have to use all the properties and all the rules we learned about logarithmic functions and exponential functions. So the first question is, if we have log base 4, and then we have a 3x here is equal to 3, how can I solve this logarithmic equation for x? For this one, it'll be best if I can convert it to an exponential equation. So when I want to convert it to an exponential equation, the base is 4, and I'm raising it to the third power. And when I do this, I'm getting a 3x. So 4 to the third power is equal to a 64, is equal to a 3x. To leave the x alone, I have to divide each side by 3. So x will be equal to, when I divide 64 by 3, I just get this as a fraction 64 over 3 because 3 cannot go into 64 evenly. So the solution set is, you're going to pick the first one, and the answer you will need here is 64 divided by 3. And then when you check your answer, you're going to see that it will work for number 1. So for number 2 here, we will get a similar equation, but little different. So for question 2, we have log base 3, and then inside the parentheses, I have 6x minus 1, and this is set to a 2. Again, the smartest way will be here, change this to an exponential equation. So the base is 3, and then 3 will be raised to the power of 2, and then when I do that, it will be equal to 6x minus 1. 3 squared is 9, so I have 9 is equal to 6x minus 1. In order to solve for x, we just have to add 1 to both sides. So 10 is equal to 6x. Divide each side by 6. So x must be the same thing as 10 out of 6. And when I simplify this fraction, it is equal to a 5 over 3. X must be equal to 5 over 3. So I'm going to choose A, and I'm going to type my answer as 5 over 3. So I'm going to come here and type 5 over 3 as the solution. For question 3 here, we have a different style question. So let's learn how to handle this one. The reason I said it's different because this question on the first side, I have a logarithmic function. I have log base 3, and then the number I have is x plus 9. Also on the right side, I have a logarithmic function, not a plain number, and it's also base 3, and the number is 8. Just like exponential equations, remember how in the exponential equations we were saying that if the bases are the same, the powers have to be equal to each other. So in this case, x must be a 5. Here, I have the log base 3, and I have the log base 3, which is exactly the same. So this will allow me to set the inside part equal to each other. That means since these two are the same, we're just going to go ahead and set x plus 9 to be an 8. And when I solve this equation for x, I will get x to be equal to a -1. That's how I am going to solve this problem. So here, rewrite the given equation without logarithms. Do not solve for x. So without logarithms, we know that x plus 9 must be equal to 8. And then we will check this first. And then this question will ask me then what is the answer next when we solve for x. We're going to get that x must be equal to a -1 for question 3. For question 4, we have log base 3, and this is x plus 4. Again, the right side starts with log base 3, and then we have a 6. Again, they both have the logarithmic function. They both have the bases the same. So we're just going to go ahead and set x plus 4 to be a 6. And then when we solve this equation for x, x is equal to a +4 because we're going to subtract 4 from each side. So we're going to say the solution set is when x is equal to a 2 for this question. And that's how I am going to do number 4. For number 5, we have this 2 times log base 12, and then here we have x minus 7 plus log base 12. This is a 4, and this is set to a 2. we're going to have to apply properties of logarithms to write this part as just one single logarithmic expression. So the 2 is a power, so 2 is going to move as a power of x minus 7. So if I start log base 12, and then x minus 7 to the second power, because of the power rules, 2 will go as a power, plus. I'm just going to copy the log base 12 and 4, and this is equal to 2. I'm going to use the properties of logarithms one more time, because I can write them as a single logarithm using the product rule. They both have log base 12, and then the first number is x minus 7 squared, and I need to multiply it by 4. This is called product rule. Remember, if they have a plus connection, you can just write them as a single logarithm by multiplying the numbers, and this is set to a 2. I can now change this logarithmic equation to an exponential equation. So the base is 12. I'm going to raise this 12 to the second power. Then I'm going to make it equal to x minus 7 squared times 4. 12 squared is just 12 times 12. And then on the right side, I have x minus 7 squared times 4. Since I'm trying to solve for x, I'm going to go ahead and divide each side by 4 first. So I can isolate the x minus 7 squared alone on the right side. And then 12 divided by 4 is 3. So the left side is only 12 times 3, which is 36. From now on, you can use different strategies to solve for x, but the easiest thing comes to my mind is I can take the square root of each side. When I take the square root of each side, taking the square root of x minus 7 squared is just x minus 7, but square root of 36 will return me two numbers, plus and minus 6. So square root of 36 is either a positive 6 or negative 6. So one of the equation I need to solve is x minus 7 can be equal to a 6. The other equation I need to solve is x minus 7 can be equal to a negative 6. When we add 7 to both sides, this one gives me a 13. When I add 7 to both sides, this one gives me a 1. Am I going to accept both of them? So one thing we have to make sure is logarithms are only defined for positive numbers. So when you are taking a logarithmic of something, this something over here must be a positive number. You cannot take the logarithmic of a negative number. So when you use 13, if it creates a negative number here, you have to exclude it from your solution. So when I use 13, I'm going to have 13 minus 7 here, which is 6, and it's good. I can use this. However, when I want to use 1, so I need to evaluate 1 minus 7. That's a negative 6, and I cannot take the logarithmic of negative 6. So this will be excluded from the solution. So for this question, it says rewrite it without the logarithms first. So when I want to rewrite this for without logarithms, I think they want me to enter this step. I'm just going to go ahead and enter 36 is equal to x minus 7 squared. Let's see if they accept this. 36 is equal to x minus 7 to the power of 2. And then when I check this answer, see, that's not what they wanted. Equation without logarithms do not solve for x. So I'm going to step backwards. Without logarithms, I have this part. Let's see if they will accept this. I have 12 squared is equal to x minus 7 squared times 4. And then when I check the answer, now they accept this answer. And then the solution set will be only just one number because we had to exclude the 1 from our solution. So the only answer will be here, 13 for this question. And this is how we are going to solve number 5. Number 6 is another logarithmic equation that we have to apply first properties of logarithms. When I rewrite this question by using the properties of logarithms, the first thing I see is 2 will be copied as power. So I'm going to write log base 4 and then x minus 5 to the second power plus, on this side, we have log base 4 of 4 is equal to a 2. I can go ahead and use the product rule here, but what I notice is something easier. Instead of keeping this complicated logarithmic function, I can just go ahead and evaluate this. Log base 4 of 4 is just a 1, because remember, log means the power. So 4 needs to have what power to become a 4, and the power you need is 1. This allows me to simplify my work. Log base 4 of x minus 5 to the second power. And then if we subtract 1 from each side, this will be just a 1. Now I can proceed from here. Base is 4, and we're going to raise it to a power of 1. And this will be set to a x minus 5 to the second power. So that's a 4. And then if I expand this, x minus 5 times x minus 5, this will give me x squared minus 10x plus 25. If you don't believe me, please go ahead and multiply x minus 5 by x minus 5 using the foiling, and you're going to end up with the same answer. The whole reason I have to do this because I need to move the 4 to the other side as negative 4 so I can get a quadratic equation to factor here. Factors are x minus 7 and x minus 3, and both of the factors are going to be set to a 0. So here now, I'm just going to go ahead and remove this part so I can have more space. First factor is x minus 7. I'm going to set this to a 0, and this will give me x equals 7. The other factor is x minus 3. I will set this to a 0, and it will give me x equals 3. The last thing I have to do is check if I need to exclude any of these solutions. When x is 7, 7 minus 5 is 2. That's a positive number, so we will accept this. If I want to use 3, 3 minus 5 is a negative 2. And we cannot take the logarithms of negative numbers. So the 3 will be excluded from the solution set. So we're going to get only one answer here. The only acceptable answer will be 7 for this question. For number 7, we have log x plus log x minus 48, and this is set to a 2. First, I want to rewrite this as one single logarithm, so I want to use the product rule. For logarithms, if the base is not given, you have to accept that they're always a 10. If the base is missing, the base will be equal to a 10. So this is log base 10, and I just have to multiply x by x minus 48 because of the product rule, and then this is equal to 2. This allows me to change this equation to an exponential equation, so base 10 will be raised to the power of 2, and then this will be equal to x times x minus 48. That's a 100. X times x is x squared. X times 48 is negative 48x. So I'm going to have to set this to a quadratic equation by subtracting 100 from each side and set this to a 0. Again, I need to factor this. So when I look at the factors of this quadratic equation, the number is negative 100. So I will need x minus 50 and x plus 2. So when I multiply these two numbers, their product is a negative 100. And when I add them up, their sum is negative 48. This will return me a 50. And then this will return me a negative 2. But am I going to accept both of them? Let's see. 50 is good. I can take the log 50, and I can take the log 50 minus 48. 50 is good. But we will have to exclude the negative 2 because negative 2 minus 48 is a negative 50. And I cannot take the log of negative 50. Therefore, negative 2 will be excluded. So this question came again in the form of rewrite this without a logarithm. So I'm going to give them 10 to the power of 2 is equal to x times x minus 48. And then for the solution set, we're going to have to exclude the negative 2 because it makes me take a logarithmic of a negative number. So only 50 will be accepted here as a solution set for question 7. Question 8 is very similar to 7. So Again, the base is 10, so I'm going to leave 8 to your own taste. For question 9, I have log 2x plus 5, and then this is set to 1 plus log of x minus 7. Since we have two logarithmic functions and we want to make them only one, I'm going to subtract log 7 from each side so that I can organize the problem as log 2x plus 5 minus log x minus 7 is equal to 1. I am allowed to write them as single logarithmic function now because of the quotient rule, because if we are separating these two logarithmic functions with a minus, that means 2x plus 5 must be divided by 7, and then we can just write one single logarithmic function. For logarithmic functions, if the base is missing, it has to be a 10. This now allows me to rewrite this as an exponential equation. The base is 10, so 10 will be raised to the power of 1, and then we're going to set this equal to 2x plus 5 over 7. So 10 to the first power is just 10, and then we're going to make this equal to 2x plus 5 over 7, and then when I do cross multiplication, 2x plus 5 will be equal to 70. And then I can subtract 5 from each side. So 2x will be equal to 65, and x will be equal to 65 over 2. Since this is such a big positive number, even though it's not a whole number, there is no problem about getting a negative number after the log function. So we're going to accept this answer. First part is rewriting this without logarithms again. So I'm just going to give them 10 to the first power is equal to, so I'm just going to write 10 is equal to, and then here we are going to divide 2x plus 5 by 7, and then check. See, it didn't accept this one, so I'm thinking that if I raise 10 to the first power, then is it going to accept this? It still didn't accept it. So it says, rewrite the given equation without logarithms, do not solve for x. Without logarithms, oh, this is not 7. Oh, I didn't even solve the problem right then. Okay, this means I am going to just, I made a mistake here when I was copying the question. This was x minus 7, and I just put it as a 7 here. So that's what I made a mistake. Therefore, it doesn't accept my answer. So we're just going to go back to this step, and then I am going to do everything again. So this is log 2x plus 5 over x minus 7 equals to a 1. And now when I convert this to an exponential equation, the invisible base is 10. 10 to the first power is equal to 2x plus 5 over x minus 7. So here, the mistake is not 7. I need an x minus 7 here. And then when I do this, now it is correct. And this means I have to just solve this equation again. 10 to the first power is just 10. So we're going to do cross multiplication. 10 will be multiplied by x minus 7, and it will be set to 2x plus 5. So that's a 10x minus 70 is equal to 2x plus 5. I'm going to subtract 2x from each side and add 70 to both sides. So x will be equal to 75 out of 8. So the expected answer will be here, 75 out of 8. And then when I check my answer, it will be correct. Number 10 is pretty much the same. So you can listen number 9 again and do this one. Here you're going to use the product rule. We did this question before. Question 12 is, again, you're going to combine these two using the product rule first and then change it to an exponential equation. To finish this video, let's just do the last one, question 12, and then we're going to conclude this video. For question 12, I have log base 2 of x plus 5. I'm adding this with log base 2 of x plus 2, and then this is set to a 2. First thing we're going to do is we will use the product rule to write them as a one single logarithmic function. So log base 2, and then x plus 5 and x plus 2 must be multiplied by each other. And then this is set to a 2. Now I'm in the position where I need to change this to an exponential equation. The base is 2, and we're going to raise it to a power of 2. And then we're going to make it equal to x plus 5 times x plus 2. So that's a 4. And then x times x is x squared. X times 2 is 2x. 5 times x is 5x. And then 5 times 2 is 10. We're going to set a quadratic equation here. 2x plus 5x is 7x. And I'm going to move the 4 to the other side as -4. So 10 minus 4 will give me a 6. So this quadratic equation will be set to a 0. Factors are x plus 1 and x plus 6. So when I multiply these two numbers, the product is 6 and the sum will be a 7. And then when I take the first one to a 0, this one gives me x equals -1. When I set this one to a 0, this gives me x equals -6. Now, am I going to accept them or am I going to reject them? -1 plus 5 is 4, so this is not a big problem. So let me do this, stop sharing, and then I am going to just share my MathLab screen now. This homework is, okay. So we were going to check the solutions we got. So the solutions we got is, where are my solutions? The solutions I got is -6 and I just can't, there's a lot of -6 and -1, -6 and -1. -1 is not a problem, but -6 is a problem. So the only acceptable answer will be here -1, because -6, when you use -6 for x, it makes you take the logarithm of a negative number. Therefore, we cannot accept the -6 as an answer, even though we got it from the quadratic equation. This is the end of section 6.6.